To deal with composite functions, let f be a function from x to y and g be a function from y to z. The domain of f is x, the codomain of f is y. Same way, domain of g is y and the codomain of g is z. So I am growing f and g. So let this be the set x, this be the set y. Then f is a function from x to y. This shows the arrow. Okay. So if x is an element, small letter x is an element of x, under the mapping f, we will get the image on y as f of x. Okay. So if it is g, the mapping will be g of x. If it is z, the mapping will be z of x. Same way as it is f, the image of x under f will be f of x. Again, what about the second function? The second function is from y to z. So already y is there. So we will draw the next set as z. And y is an function from, g is a function from y to z. Now what you have to do is, f of x is an element of y. F of x is an element of y and the mapping given or the function given is g. So can you say the image of f under f of x under g? It will be g of f of x. Okay, so x is having the image of f of x under f. F of x is having the image of g of f of x under the function g. And we can define a mapping from x to z, function from x to z. And its name is given by g composite f. The function is from x to z, set x to set z, and the name of the mapping is given as g composite f. And the definition is g composite f of x is defined as g of f of x. G of f of x. X in the image is f of x and image of f of x is g of f of x. That means image of x under g composite f is g of f of x, and the composition definition g composite f from x to z is defined as g composite f of x is equal to f of x. G composite f of x is equal to f of x.